The sun is a source of heat that powers life on Earth. It's not only hot, but its temperature can change wildly with time. At times, these sudden changes can affect planets orbiting it. For example, flares or the rapid release of higher energy radiation can destroy atmospheric gases such as ozone. Ozone is important because it protects surface life from harmful ultraviolet light. If we want to search for life on other planets, we need to understand how flares from other stars could influence the planet's habitability or likelihood to support life. Planets may or may not have a magnetic field like we do here on Earth. On a magnetized planet, charged particles emitted from the star, which can be harmful to the atmosphere, are slowed down and deflected to the poles. On an unmagnetized planet, however, the charged particles get directly deposited to the dayside hemisphere facing the star. One interesting possibility is that these charged particles interact with atmospheric gases and produce nitrogen oxides. This may hint at an Earth-like atmosphere. This is because nitrogen and oxygen imply a viable habitat and potentially the existence of life. To find out if certain gases are present on the planet, astronomers look at starlight passing through the planet's atmosphere. This is because certain gases only absorb certain wavelengths of light. This technique is called transmission spectroscopy. We use these data as inputs to a 3D global chemistry climate model to simulate the response of exoplanet atmospheres to incoming flares. Our study finds that flares can affect the planet's transmission spectrum, such as signals of nitrogen and hydrogen compounds. However, many of these problems, such as the way the atmosphere circulates, are inherently 3D, and hence will need to be further studied with other high-resolution 3D modeling tools. So, knowing whether a planet is habitable for Earth-like life is an extremely challenging problem. To tackle it, scientists will need to push the limits of observational techniques, instrumentation, theory, and computer modeling. The next few years are bound to be exciting.